First Bronze, and for today we're going to be working on answering word problems involving quadratic functions. One of the challenges of answering math problems is working with word problems. And the reason why this is challenging is because the equation that we normally just solve from a math problem, now we're going to generate it based on the words that we are reading from the word problem. And that's what we're going to be working on for today's lesson on application of finding the solutions of the quadratic equations using a word problem or given a word problem. So for the first word problem that we're going to be working on, we're going to find the length and the width of this rectangular field. So from our word problem, it says here that the area of the rectangular field is 2,000 square meters and its perimeter is 180 meters. Now, how are we going to find the length and the width of this rectangular field based on the perimeter and the area given? We're going to first visualize our word problem. So we're given the area of a rectangular field, which is 2,000 square meters. So this is our rectangular field that measures 2,000 square meters. And we are also given the perimeter or the length of your rectangular field around your rectangle, which is 180 meters. So the perimeter, if you want to visualize it, is going to be the measurement of the length around your rectangle, and it's 180 meters long. So what we need to do is to find the length and the width of the field. So what we are going to first do is to identify which one is the length and the width of our rectangle. So I'm going to identify my length as the vertical measurement of my rectangle, and the width will be my horizontal measurement of my rectangle. So now that I have a visual of what we're looking for, we're now going to use our algebra skill to write the equation of our word problem. So the first statement, it says there, we have the area, and the second statement, we have the perimeter. So let's start with the perimeter. So the perimeter is, as we know, has a formula of P equals twice the length plus twice the width. And the area of a rectangle is given by the formula length times width. Now notice that in algebra, the more letters that we're going to be looking for, the more difficult and complicated our equation or procedure will be. So the next step that we're going to be doing, and this is the technique that I usually tell my students, is once you establish your equation from the word problem, we need, or our next goal is to write the formula into a single variable equation. And in this case, since we have two variables that we are playing with, the length and the width, or the L and W, let's modify our first formula, which is the perimeter, into a formula with respect to L or with respect to W. It doesn't matter which one you want to use, but I will use it with respect to L. So how am I going to do that? So P, the general formula for the perimeter is P equals twice the length plus twice the W. Now I know that the perimeter is 180 according to the word problem. So I'm going to modify my formula according to the word problem, and I've noticed that 180, 2, and 2 can be simplified by dividing all of them by 2. So now my formula will be a lot smaller to work with because half of 180 is going to be 90. So I have 90 equals L plus W. And now that I have a simpler formula and I want L to be by itself because I'm going to work with the variable L instead of W, but again, it doesn't matter which one you choose. So I'm going to subtract W on both sides so I can modify my original formula into a single variable formula with respect to L. So now my L is equal to 90 minus W, and this equation right here is what will help me to work with the area of the rectangle that we have formulated from our word problem, or the second statement of our word problem. So now that we have our modified version of the formula for the perimeter with respect to the word problem, which is giving us 180 meters as the length of the rectangular field. So now I have L equal to 90 minus W. And now that I have this equation, I will move to my area, or the formula for the area of the rectangle, which is length times width, and modify L into 90 minus W. So now I'm going to replace L with 90 minus W, and I'm going to manipulate my formula according to the given information that we have at hand. So now that we have A is equal to 90 minus W times W, I can distribute W, giving me 90W minus W squared. And I know that my area in this problem is given, which is 2,000 square meters. So I'm going to replace A with 2,000. And now I have my quadratic equation. And from here, what I can do is I can equate this to 0, and I will equate it to 0 by making sure that my quadratic term is positive. So my next technique that I'm going to use is add W squared on both sides. So I have 2,000 plus W squared equals 90W, and then subtract 90W on both sides, and I'll have 2,000 plus W squared minus 90W equals 0. So now my quadratic equation is equal to 0, but I'm still going to manipulate this so that my equation will be in standard form. So I will clean this up, and now my final quadratic equation will be W squared minus 90W plus 2,000 equals 0, because now my quadratic equation that I'm going to be using is going to help me answer my word problem, because my quadratic equation will lead me to solving or finding the solutions of the quadratic by factoring, completing the square, or quadratic formula. And I know that this particular quadratic equation is factorable, and to be able to do that, you need to know your multiplication table really well. So how are we going to factor this out? So we're factoring it out by W squared minus 90W plus 2,000 equals 0. What we need to do is to find the factors of 2,000 that when we add them up will equal to negative 90. And by that, I know that my factors will both be negative. And the only challenge now is to figure out those two factors. And those two factors that will give me negative 90 when I add them up is 50 and 40. So negative 50 times negative 40 is 2,000. And negative 50 plus negative 40 is negative 90. So my solution for my quadratic equation using the zero product property will give me W is equal to 50 and W equal to 40. So now I have two sets of measurements for the width in this particular calculation, and we're going to use that in finishing and completing our word problem. So by factoring, we're able to produce the two solutions or two possible values of the width that will satisfy our word problem. One is at W equal to 50, and the other one is W equal to 40. Now, we know that multiplication is commutative, so it doesn't matter what value you're going to use for your length, and it will still be equal to the calculated length that you're going to be that we're going to be generated from our formula. So what you can do is you can use this to find the value of L, or this formula to find the value of L. You can also use this to find the that value of your second L. So I'll use this instead. So if I'm going to use the formula for the area, which is 2000 equals to length times 50, when W is 50, by dividing both sides by 50, I will find my value of L. So if the width is at 50, my length is going to be 40 meters. Now, what about the other W? So that means let's try it out when W is equal to 40. So I'm using the same formula for the area, and I will replace W with 40, divide both sides by 40, and I've noticed that it's just switching. So if my W is 40, my length is going to be 50, which is basically switching our L and W's around with these two possible values of our width. So in this case, it's safe to say that the dimension, since we know that the length and the width of our rectangular field, even if you switch it around, the area and the perimeter will still be the same. So my dimension for this rectangular field is going to be 50 by 40. Now I'm going to give you a technique on how you can use technology if you're not sure on how to figure out the factors of your quadratic equation. So what you can do is use Desmos, plug in your equation. So our equation was W squared minus 90W. So let's see if W can work. W squared. So it's not working with W. Let's use X instead. So X squared. Now we're seeing a parabola. X squared minus 90X plus 2000. 2000. And since our range of values here is pretty small, so let's make it bigger so that we can find the parabola that we're looking for. And the parabola is right over here, and it's giving me 40 and 50. So this is one strategy that you can use so you can find the factors of your quadratic equation when it's a little bit too big to manipulate. So this is one strategy that you can use when you are practicing your word problem skill. And again, using technology is not cheating. It's just helping you be able to be more confident. And the more you practice your math problems, you will be able to develop your skills on how to manipulate those factors in your head, which takes a while for some people, but for some people, it comes to them naturally. But we just need to figure out what will work for us so that we'll be able to answer this problem according to how we are understanding this challenge. So speaking of challenge, let's have our next challenge, and that is to solve our second word problem of the day. So now we know that what we're going to do is to first write the equation based on the word problem, and then the second step that we're going to do once we laid out all our equations or formula is to modify the formula into a single variable so that we can find the quadratic equation that will help us solve this problem. So in this word problem, we're looking for two numbers. And the clue in this number or in this word problem is that the sum of the two numbers is 19. So that's the first statement. So let's translate the first statement, which is pretty straightforward. Sum of two numbers is 19. We can represent it as a plus b is equal to 19, x plus y is equal to 19, or other letters that you want to use, or shapes, if that's how you work out a word problem, but in this case, I will use x plus y. So I have x plus y is equal to 19. That's the first statement. And then the second statement is a little bit challenging because there are so many words associated to the second statement. The sum of the squares of the number is 193. So we need to find the sum of those numbers that is equal to 193. And what are those numbers? According to the problem, it says the squares of the number. And what are the numbers that we're working on? Obviously, it needs to be related to the first statement that we have. Since we have x and y as our first two numbers, let's use it and let's square those numbers. So now we have x squared and y squared. And to complete our second statement, The sum of the squares of the number is 193. So now I can easily lay out my equation for my second statement, which will be x squared plus y squared equal to 193. And now that I have my two equations, that's all we need so that we can find those two numbers, just like what we did from the first problem. We're going to modify our formula so that it will look like a single variable formula. So for x plus y is equal to 19, I'm going to subtract y on both sides so that I can have x as my chosen variable to use. So my formula for my first statement is going to be with respect to x, and that x is equal to 19 minus y. And for my second statement, x squared plus y squared is equal to 193. Now I'm ready to modify my x so that it will all be just y variable. And to do that, x is now going to be 19 minus y. And now the challenge is to expand 19 minus y quantity squared, because this is an example of a square of binomial. So what we can do is we can FOIL it out and then find the product of 19 minus y times 19 minus y. So let's go to our handy dandy whiteboard and figure out the product of 19 minus y quantity squared. So there are two ways on how to do this. You can do it horizontally, 19 minus y times 19 minus y. Multiply, 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 or you can also do it vertically, which is what I'm used to do. So I have 19 minus y times 19 minus y. So how am I going to produce my square of binomial? 19 times 19 is 361. 19 minus y is negative 19y. Negative y times 19 is negative 19y, and negative y times negative y is positive y squared. And by this method, I'm just going to add them up. 361 is by itself. Negative 19 minus negative 19 is going to be negative 38y plus y squared. And now I have my quadratic equation, which what I'm going to use so that I can modify or simplify my equation. So now that I was able to expand my x squared into 19 minus y quantity squared, which is 361 minus 38y plus y squared, all I need to do is to bring down the rest of my equation and equate it to 0. So let's subtract 193 on both sides so we can combine like terms and combine 361 and 193 by subtraction and add y squared and y squared so that our equation will now be 2y squared minus 38y plus 168 equal to 0. And this is the equation that we're going to be using so we can find the two values or two possible values of y in this problem. So there are three methods that you can use, whichever is easier for you: factoring, quadratic formula, completing the square. My choice of weapon is, what am I going to use? Let's see. I'm going to use factoring. Factoring because I can take out the 2 in my quadratic function. So this will become smaller. So this is going to be y squared, half of 38. 38 divided by 2. So half of 38 is going to give me 19. And half of 168 is 84. And now I have a smaller version of my, this is 84, not 89. A smaller version of my quadratic function, which I can now factor out a lot easier because I need to produce positive and negative. So that means two negatives will give me positive when I multiply it, but when I add them up will give me negative. And those two factors of 84 that will give me 19 is, I know my multiplication table really well. It's going to be 12 and 7. So now my values of y is equal to 7 and y equals 12. And now I was able to produce the values or possible values of y's that we're looking for based on the quadratic equation that we're able to generate from our word problem. So now that we have the two values of y is equal to 7 and y is equal to 12, just like what we did on the previous example, if you plug it into any of these equations that we have, you can plug it in here or here or here so that you can find the second number that we're looking for. It will just be the same values, and switching y and 7, y and 12 will just generate the same value of the equation, which is 19 and 193. So if I replace y by 7, and this is equal to 12, so all I need to do is 12 plus y is going to equal to 19. And if I'm going to square my numbers, which is x squared plus y squared, I will have 49 plus 14, which is also equal to 193. And again, if you want to use your Desmos, so let's use Desmos for students who are still trying to master their skill on factoring. So again, you can write 2x squared, which is our quadratic function, minus 38x plus 168. And in this case, we'll be able to find our solutions, or the clue to our solutions, 7 and 12, which is what we are looking for in the two numbers for this quadratic equation. So again, practice is key so that you'll be able to gain confidence on working with problems similar to what we just did. So the challenge, the third challenge for the day is our Numberbender challenge. So let's see if you can answer this word problem using the technique that I just shared to you. Two squares have sides p centimeters and p plus 5 centimeters. The sum of their squares is 625 square centimeters. Now, let's find the length of the sides of this square that we are working for or working on in this particular word problem. So again, remember that when you are working with word problems similar to this one, all you need to do is to be able to translate our word problems from verbal to algebraic statement and then manipulate your formula into a single variable equation and produce the quadratic functions that you're going to be using so that you can find its solution by factoring quadratic formula or completing the square, so you can find the items that you are looking for in this word problem. So practice makes perfect, and make sure that you're practicing correctly. So feel free to use technology to verify your work, and it will help you gain confidence in working with problems similar to what we are working on in this video. This is Dr. E, and see you again next time. Bye!